Hey guys, welcome back to my channel, and in today's video we are going to solve one more LeetCode question, that is 977 squares of a sorted array. So this is also a easy level question, and this has been asked by these many companies in last 2 years, which is a lot. So let's see what this question is all about. So in this question we are given an integer array in nums sorted in non-decreasing order or increasing order, and we have to return an array of the squares of these values in sorted non-decreasing order. So firstly, this is the input where we can see the whole array is in sorted order and it consists of negative values as well. But after this array has been squared, or the values of this array has been squared, we can see again they are in sorted order, and that is what the output is. So once the values are squared, we have to maintain the sequence, that is they should follow that non-decreasing order format, and then we will be returning them in a form of out. So let's see how we can solve this question using this example. So the first brute force approach that at least I can think of was, firstly let's simply square all the values. So this will become 25, 16, 1, 0, 4, 9, 100, right? And this is the squared array. Now we will sort this whole array, and this will become 0, 1, 4, 9, 16, 25 and 100, and that's it. So the values are squared as well as they are in sorted order, and then we can return this whole thing as a result. So the first time when we were traversing this array and creating a squared array out of it, it will take big O of n time, and second time when we are sorting this whole array, it will take big O of n log n time, and overall time complexity will become big O of n log n time, and space complexity will be big O of n or big O of log n, because this depends on the sorting mechanism and the programming language that we are working with. So this is the whole time and space complexity of the brute force approach. So can we do better than this time complexity? Then it's yes, because we hadn't utilized the input properties that is being provided to us. We have directly jumped to a conclusion, and we have created a solution out of what is being demanded in the output. But rather than focusing on output, if we would have focused on the input a bit more, we would be able to come up with a more optimal approach. So let's now focus on our input first, and then we will see how we can optimize this whole solution and time complexity. So now let's firstly see what all input properties we do have. So first thing is that our input array is sorted, and it consists of two types of values, that is positive and negative values. So this is what is present in our input. Our whole input is sorted and it consists of positive and negative values. Because it is consisting of two types of values and it is sorted, so we can divide this array in two portions, that is first one is the negative value portion and second one is the positive value portion. Now our array consists of two parts. First one is having negative values and second one is having positive values. So if we want to traverse this array only once, we need to create two pointers, so that one pointer will take care of this part and another pointer will be taking care of this part, right? So we will exactly do the same thing. So we will firstly create a left pointer and a right pointer, where our left pointer will be at the extreme left side, so it will be at 0, and right pointer will be at extreme right, so it will be at the last, so that will be n minus 1. Right? So currently they are at this place, this one and this one. Now what we can do is, we know that our array is in sorted order, right? So even if values are positive or negative, when we are going to square them up, they are going to become positive, right? And at the end, right now we don't know which is the greatest value, because possibility is this value might be, rather than -5, it would have been -55. So if I would have squared it up, it will become greater than this 10, right? It will become greater than this 10. That's why we can't come up with the claimation that the left side values are going to be inserted first in a resultant array, or the right side values are going to be inserted first. So for that, what we can do is we can simply compare the absolute values of these left and right pointers. So what we can do is, as left is at this place and right is at this place, so let's compare these two values first and we will see which one is the greatest. So right now we can see that the right pointer's value is greatest. So what we can do, we can simply square it up and we can place it in the resultant array at last. Because we know that our nums array is sorted, so whichever value is going to be inserted here will be the greatest one. We are sure about it. So that's why we are inserting at the last position in our resultant array. Now after this, what we will do, we will update our right pointer and we will decrement 1 from it. So previously our right pointer was at which position? It was at 6th position. Now it will be at 5th position, right here. And our left pointer is still at 0. So now again we will do the same thing, that is comparing the absolute values of both the pointers. So this time we are having left pointer's value greater than the right pointer's value. So what we will do, we will do the same thing. We will update it, square it and update it in our resultant. So here is the 25. And then what we will do, we will increment our left pointer. So rather than 0, it will become 1 and will go to this place. And again we are going to do the same thing. Whether left value is greater than right value, we can again see that left pointer's value is greater. So we will square it and update it in our resultant and update our left pointer, so it will come up to here. And then again we will do the same thing, -1 or 3, which one is greater? So 3 is greater. So we will square it up and update it in our resultant array and update our right pointer. It will come to 2. Again we will compare -1 and 2 and we know that 2 is greater. We will square it, place it and again move our right pointer to this direction, in this direction, and again do the same thing, left or right. We know that 1 is greater and then 0. So this is how we proceeded. Firstly, we have checked the values at both the places. Then after getting the greater value, checking the absolute values of both the pointers, finding the greater one, squaring it up and updating it in our result. And that's how we will get our resultant array and then we will be returning it. So this whole approach will take how much time? As we are traversing this array only once, so the time complexity is big O of n, and space complexity if the resultant array is not considered or the resultant data structure is not been considered in the space complexity, which you can get to know from your interviewer. So you can have a conversation with them that this is being considered or not, and if it's not, then this whole algorithm is of big O of 1 space complexity, else it will be of big O of n space complexity. So depending on the acceptance from your interviewer, this is the space and this is the time complexity. And I hadn't updated the indexes here, but these are also going to be updated depending on the changes that we are making to the pointers, right? So this was the whole algorithm. Now let's quickly code this whole solution. Firstly, we'll code a Python solution and then we will do Ruby. So firstly, let's calculate the length of this array. After this, we will create a resultant array and it is going to be of length n. After this, we are having a pointer left, which is 0, and right, which is going to be n minus 1, and we are running a loop. So for I in range, and this will be from the last to the first. So for that, what we can do is n minus 1 to -1 and run it in reverse. After this, inside this for loop, what we were doing, we were checking the absolute values of the pointers, right? So at nums left, whatever value is there, we want to check whether this value is less than absolute value at nums right. And if this situation is true, then we know that the right value is greater, so we will update our result I with nums right into nums right, and then update our right pointer with minus equivalent to 1. If this isn't the case, then what we will do, we will update our result I with nums left into nums left, and left plus equivalent to 1, and after stepping out of this loop we will return our result. So this is it. Now let's quickly try to submit this and check. So we can see that this has been accepted. And now let's quickly code Ruby solution. In Ruby as well, we will do the same thing. Firstly, we want to check the length. Then we want a resultant array. So for that, we will do array.new and pass the size and the default value. After this, we will define a left pointer, which will be 0, right pointer, which will be n-1, and we want to run a loop from n-1 to down to 0 and do with I. And inside this loop, this is a for loop which will run from n-1 to 0, and I will be the pointer. And with this, what we will do, here we will create a if case similar to the Python one, that is if nums left dot absolute is less than nums right dot absolute, then inside this if, update our result I with nums right into nums right, and then update the right pointer with minus equivalent to 1. And if this is not the case, in that situation we will update our result I with nums left into nums left, and after this we will update our left pointer with plus equivalent to 1. And after stepping out of this loop, we will return result. That's it. Now let's submit this, and we can see this is also accepted. So this was the whole solution and explanation. I hope this video was helpful for you all, and if it was, then don't forget to like, share and subscribe my channel. I will soon come up with more such questions. Till then, keep messing with algorithms, and thanks for watching.